All right. Next topic is going to be integration by parts. This leads us into a variety of techniques for integration. Quick review, though, before um, we dive into that. So here's the basic integration formulas that you want to try and have down. And these are probably in most textbooks. They're in one of the covers, back cover, front cover. So in the first few pages, and definitely they're there in the appendix. But these are kind of like the basic formulas. They've all been proven at one stage or another um, at up to this point. So these are the ones we want to kind of remember as best we can, right? At the very least, remember that they're ones we should know. Okay. Some of these are a little more difficult. 13. Well, really 12 through 17 might be a little trickier ones you don't see all that much. 1 through 11, even the inverse tangent one, right? Should definitely try and remember those. But anyway, so those are the basic integration formulas. What comes next then is what do we get when we have some more complicated things? And that's where techniques like integration by parts comes in. Okay. So this is the formula, but before we even get there, let's kind of let's build up to that. Now, since we just did an example of a center of mass, we can look at, let's suppose we have a um, let's suppose we have a thin bar whose density function is simply e to the x. Okay. Well, the mass, the integral from a to b of e to the x dx, no problem. But now the total moment is the integral from a to b of x times the density e to the x dx. This is hard at this point. This is easy. It's e to the x. Simply adding an x to it suddenly turns it into something more complicated. Okay, and that's where integration by parts comes in. So we're going to do substitution. Remember, you use substitution. That kind of emerges out of starting with the chain rule and kind of working it a little bit. And the same thing is going to be true here with the integration by parts. Only now we're going to start with the product rule. Product rule for differentiation was d dx of u of x times v of x. That's u prime v plus u v prime. And what we want to do is we want to integrate both sides. Okay, well, this side just gives us u of x v of x, so that's easy. This side gives us the integral of u prime of x v of x dx plus the integral, right? Got an integral of a sum is the sum of the integrals, right? Integral of u of x v prime of x dx. Okay. All right. And so now what we're going to do is we're going to um, get the u v prime all by itself. Okay, so we're going to put this uh, by itself. So subtract. So we subtract this from both sides. And so we have the integral of u of x v prime of x dx equals u of x v of x minus this piece, the integral of u prime of x v of x dx. All right, now what we're going to do is we call this part Okay, if you think about, right, what is v of x? I'm going to take the derivative. So if u equals v, if we were to do the chain rule rather, so just take the derivative, right? D dx, you're going to get v prime of x dx. Okay, so if v equals v of x, dv is going to be v prime of x dx. And so this becomes dv. And so we get the integral of u dv, okay, uv minus, same thing with u prime. If u equals u of x, then du equals u prime of x dx. And so the u prime dx becomes the integral v du. And this is our integration by parts formula. All right, so integration by parts. U and V are differentiable functions. The integral of u dv equals uv minus the integral of v du. Okay, great. But what does that mean? How do we do that? And that's what some examples are for. So let's jump to an example before we get to this. So jumping to our example, let's do our simple integral we introduced before, seemingly simple, but hard to integrate. The integral of x e to the x dx. Okay. Now, our formula is the integral of u dv equals uv minus the integral of v du. And so the question in integral by parts is, what is u and what is v? Okay, and so what is u, what is du, what is dv, all those things kind of drop out. And so in our formula here, we want the integral of u dv. That's what we got. So u here must be x, and that means the dv must be e to the x dx. And so we have u equals x, dv equals e to the x dx. And so now those are the, so I should put it this way. What is dv? Okay, so what is u, what is dv? And then from there, what is du and what is v? Once you know what u and dv are, you can find the other thing. So du equals dx. How do we find v? Well, we got to integrate, right? Okay, so the integral of dv is just v, and the integral of e to the x dx is e to the x. Okay, so now let's plug that into our formula. So the integral of x e to the x dx, if I'm going to do integration by parts, is uv. So that means that's x e to the x minus the integral of v du. So that's e to the x dx. Okay, well, we know how to, so x e to the x. We know how to integrate e to the x, so that's just e to the x. And then, of course, once you do your last integral, don't forget your constant plus c. There we go. That's integration by parts. All right, so we can do another example here then. Okay, another seemingly simple example. Well, we know what the integral of x or sine x is. Let's throw an x in front of it. So what's the integral of x sine of x dx? Okay, again, here's our formula. Integral of u dv is uv minus integral of v du. And so the question to use integration by parts is what is u, what is dv, and then we can find du and v. So here, u looks like it's going to be x to us. So the good candidate for dv is going to be sine of x dx. So if u equals x, dv equals sine x dx, then du equals dx, and v is the integral, it's going to be negative cos x. Negative cosine x. Okay, so then our formula, integral of u dv, so u v, so that's going to be negative x cos x minus the integral of v du, okay? And so this becomes negative x cos x plus the integral of cosine x dx. Well, integral of cosine, sine, so this is going to be sine of x minus x cosine x. And just rearranging those again, plus our constant c. All right. Now let's do a more complicated one just to see what we might run into. Okay, sometimes integration by parts is the right strategy, but it doesn't work right away. Okay, we got to do it a couple times. So let's look at, for example, the integral of x squared e to the x dx. Okay, so again, it looks like x squared. So what you want to do is when you apply this, you want to try and simplify, right? So that's why we're usually going to take, so the candidate for u is probably going to be x squared because we do du, that's going to give us 2x dx, that's quote simpler. Okay, if we were to make this dv, then that would give us x cubed over 3, and that's kind of moving in the wrong direction. So if we say that u is x squared and dv is e to the x dx, then that gives us du 2x dx, and v, again, is just e to the x. And so integration by parts formula, the integral of, that's going to be uv, right? So that's going to be x squared e to the x minus the integral of v du 2x dx. All right, well, that's better, but it's not quite there. So we've got this second integral isn't easy to do like the previous examples, but it's not impossible either because we recognize that that's just another integration by parts problem. Okay, and so let's rewrite this. So the first part is x squared e to the x minus, I'm going to switch this to x e to the x dx, right? And so now let's do integration by parts again for this one. So let's do a little sub thing here. Okay, remember u was x, so d, so and dv was e to the x dx. So from before u, so that's x e to the x minus the integral of v du. So that's minus the integral of e to the x dx. And so it's a 2 times this, right? And so 2x e to the x minus 2 e to the x plus c, but now we got to put this back up there. Okay, so x squared e to the x minus 2x e to the x, and then the second one becomes a plus 2 e to the x plus our constant c. So this is our final answer. Okay. All right. So sometimes integration by parts has to be used repeatedly. Okay. There's a simpler extension. Integration by parts can be applied to definite integrals also. Okay. Same idea. It's just now instead of the plus c, you're evaluating each piece at the appropriate bounds. And the second integral, right? The integral in the integration by parts formula becomes a definite integral also. All right. Final thing for here is the integral of the natural log of x